Hello and welcome to my YouTube channel. Today we'll now be discussing about some applications on the normal distribution. So there are basically two areas or two major applications of the normal distribution. The first one is what we call the infinite population, or applications regarding infinite populations, and we have also applications of normal distribution regarding finite population or finite samples. So basically today we'll now be discussing about the infinite population. Okay, so let's get started. So suppose we have a light bulb that has a lifespan of 150 hours, or the mean lifespan is 150 hours with a standard deviation of 10. What is the probability that it will last? A, less than 125, B, greater than 165, and letter C, 135 and 170 hours. So in these three questions, we need to do different kinds of solutions to this. So in this, the first, since we're talking about less than, so we will be producing or solving for the probability regarding a, or we will be doing a solution related to the answers or question in less than. So before we start, let us first identify our population mean. The population mean is simply equal to the population mean is equal to 150 hours, this one, and the standard deviation is this one, so standard deviation is 10. Okay, next is solving for A. So you will simply solve first the Z value, and for this one our X value will be, we will let the X value to be 125, this one. So using the formula for the normal distribution or Z score, we have Z equals X, or the row score, minus the mean, which is this one, mean, over the standard deviation. So in this example, so we have X is 125 to 125 minus mu is 150, and the standard deviation is 10. So we have our Z will be negative 25. We'll just simply subtract these two numbers, so we will be having negative 25 and then copy 10. Okay, next is to divide these two numbers. So negative 25 divided by 10 is negative 2.5. So that's the Z score for the X value, or the row score value of 125. So since the problem is, or the question is pertaining to less than, so if we draw a normal curve, and this is 0, then to the left are negative 1, we have also negative 2, and our negative 2.5 is somewhere here. So this is the less than. So in other words, the probability should be small, since the area under the less than z equals negative 2.25 is this one. So looking at the z table for negative 2.5, we have negative 2.5. So this is the probability 0.0026. So we have the probability of z less than negative 2.5 is simply equal to 0.0062. Okay, that's how we're going to solve for the problem related to less than. Now for greater than, the approach here is to do steps on, or the solutions on greater than. So the first step is simply again solve the z-score, and let us try to draw the diagram in order for us to conclude the p of z, or the probability. So since x is 165, so letter b, x is 165. Then the mean is, again from the above, this is 150. Then standard deviation is 10. So z, solving for z, we have z equals this one, 165 minus 150 all over 10. So we have 165 minus 150 is 15. Then copy 10. Then after subtracting, so we will need to divide these two numbers. So z will be 1.5. Okay, let's go back to the question. Okay, since the question is greater than, so if we draw a normal curve, this is the normal curve, then 0 is at the middle, then to the right is positive 1 and positive 2. 1.5 is in between of 1 and 2, so basically this one is the portion of the score of 1.5 or greater than 1.5. All the scores greater than 165 or z equals 1.5. So to answer this one, so you will just simply look for the value of p of z, probability of z greater than 1.5. Since we're dealing with 1.5, we will just simply look for the value of z equals negative 1.5. Since the property of greater than, the probability of z, any property of z greater than a number is simply equal to z equals its negative, or the opposite number. If this is positive, so we will look for the negative, and if it is negative here, we will look for the positive on the z table. So we have negative 1.5, so we have negative 1.5 is this one, 0.668. So in other words, this is 0.0668, meaning to say that the lifespan, or the probability of having a lifespan greater than 165, is 0.0668, or in percent times 100, this will be 6.68%. Okay, so we're finished with less than, greater than. Let us now proceed to in between. So for in between, we need to first solve for the z-score of 135 and also the z-score of 170. Okay, so we have, for letter C, we have x equals 135. Okay, so we will have z sub 1 equals 135 minus 150. Oh my goodness, this is 150 all over 10. 150 is the mean, this is the standard deviation, this is our x. Next is to subtract these two numbers, so this will become negative, how much is this? This is negative 15. Negative 15 all over 10. Then dividing these two numbers, this will give us a number of negative 1.5. So we're done with z sub 1 for 135. So for the z sub 2, x is 170. 170. So z equals z sub 2 is 170 minus 150 over 10. This is our x value, or the raw score. This is the mean and this is the standard deviation. So we have, subtracting these two numbers, this will give us a number 20. Copy 10. Then after subtracting these two numbers, divide this 10, 20 and 10. So this will come 2 or 2.0. Now since we're dealing with in between, so let us first draw the normal curve. The normal curve will be this one, and then at the middle is our 0. Then to the right of the score z is, or the normal curve is 1, and we have 2, we can also have 3. Then to the left will be negative 1, this is negative 2, negative 3. So let's plot negative 1.5. Negative 1.5 is in between negative 1 and negative 2. So let's have this one. Then z equals 2 is basically here. So in other words, the scores between 135 and 170 is located, or are located here, in between of negative 1.25 and 2. 1.25 and 2. So if we look at the graph, we can automatically say that this, or the probability, is bigger. So to do that, let us now solve for the probability. The probability will be z, or negative, the probability of z between negative 1.5 and 2.0 is simply equal to P of Z equals copy 2.0 minus P of Z equals negative 1.5. So the negative 1.5 will be the second, and the 2 will be the first here. So you'll just simply exchange the numbers to get the answer of this one. So 2 would be Z equals 2.0 is this one, 0.9772. 0.9772 minus the negative 1.5. If we take a look at our previous example, that was this one, or if we look at the Z table, negative 1.5 is this one, 0.0668. Then subtracting the two probabilities, this will give us a value of 0.9104, or in percent this will be 91.04%. So that confirms the 91%, the 91.04% confirms that the probability is large based on the graph and the calculation. So that's it. That's how we're going to solve for the problems involving normal distributions, or the applications on normal distributions in or involving infinite populations. So comment down below if you want to know more about topics related to statistics and probability. And on the next video, I'm going to share with you the steps on how to solve for the normal distribution, or applications on the normal distribution with finite population or finite samples. If you find this video valuable enough, so don't forget to subscribe and hit the bell button to get notified with the future uploads, and share this one so that everyone else can or will know about this channel and will learn about statistics and probability.